Lecture 4 for Urantia University, Paper 41, Sections 8, 9, and 10. This is Dick Bain, the instructor for this course. Section 8, Solar Energy Reactions. In paragraph 1 of this section, the authors state that stars encircuited in the energy circuits of the universe achieve fusion of hydrogen to helium with the aid of carbon as a catalyst. Modern physicists picture the process as being more complicated. First, for stars the size of our sun or smaller, the majority of fusion comes from a process called proton-proton chain reaction. This process was first proposed by Eddington in the 1920s. In stars more than 1.3 times as large as our sun, the fusion process is largely caused by the CNO cycle, in which carbon, nitrogen, and oxygen all act as catalysts. The CNO cycle was first proposed in 1938. While the authors are correct, carbon is certainly a player in the fusion game. It certainly isn't alone on the field. The author's description of the end state for smaller and larger stars agrees with the current theories of astrophysicists, in contrast with earlier sections of Paper 41, which do not agree. And one part of Section 8 is thought to be prophetic by some in our community. Quote, "The gravity-electric changes give origin to vast quantities of tiny particles devoid of electric potential, and such particles readily escape from the solar interior, thus bringing about the collapse of a gigantic sun within a few days. It was such an emigration of these runaway particles that occasioned the collapse of the giant nova of the Andromeda Nebula about 50 years ago. This vast stellar body collapsed in 40 minutes of Urantia time." Unquote. This is obviously referring to neutrino outflow, though the authors don't use the term neutrino. Matthew Block, an intrepid researcher of the sources for parts of the Urantia Book, found that a book by Gamow and Schoenberg in 1941, Neutrino Theory of Stellar Collapse, predicted that neutrinos might be responsible for the rapid collapse of a supernova. However, the book was very speculative because the neutrino had not yet been detected. It is now known that there were additions to the Urantia book up until 1942, so information about neutrinos and supernovas could have been added before publication. Physical evidence for the role of neutrinos in supernova collapse was not discovered until observation of a supernova in 1987 known as SN 1987A. Several neutrino detectors around the world detected neutrinos from SN 1987A. These were actually antineutrinos. Another piece of information contained in Section 8 is that regarding the Crab Nebula. The authors speak of the mother sphere as a lone star near the center of this irregular nebular mass. In fact, the mother sphere is a neutron star and was first detected in 1942 and determined to be a pulsar in 1968. The nebula that resulted from this supernova can be seen in the current slide. Section 9, Sun Stability. In the first sentence of this section, the authors again intimate that light consists of electrons rather than photons. They also speak of the great loss of energy due to ultramatonic leakage. Since our physicists have not detected the ultramoton or even theorized it, there is no way to compare the statement in the Urantia book with current science. Hopefully this particle will be detected before long, thanks to the work going on at the Large Hadron Collider in Europe. Finding this particle would cause a revolution in particle physics. Since ultramatons are not affected by linear gravity, they should be able to easily escape any star. Neutrinos are also able to easily escape the sun or another star, but the two particles do not seem to be the same thing with different names. Physicists now think that neutrinos have a small mass. Ultramatons apparently do not. In paragraph 3 of this section, the authors state that our sun loses almost 100 billion tons of actual matter annually. unquote. Eddington states that the mass loss from the sun due to radiation is 120 billion tons per year, which is quite close to the 100 billion tons given in the Urantia Book. Wikipedia and another source give the mass loss as 134 trillion tons per year, about 1,000 times more than Eddington calculated. We should consider that our astronomers have been observing and gathering data about our sun both from ground telescopes and later from space for about 90 years, since Eddington published Stars and Atoms. So considering the better data available, the large difference should not be surprising. The authors also state in this section that our sun will shine on at about the same level for about 25 billion years. Our astrophysicists give it about 6 billion years, at which point it will swell into a red giant. The shorter life is no doubt due to the greater mass loss per year predicted by modern-day astrophysicists. Section 10. Origin of Inhabited Worlds. As in other sections, this section also has some information that disagrees with current scientific thought. In paragraph 1, the authors state that your sun was in just such a state of mighty pulsation when the massive Angona system swung into near approach, and the outer surface of the sun began to erupt veritable streams, continuous sheets of matter. This kept up with ever-increasing violence until nearest apposition, when the limits of solar cohesion were reached, and a vast pinnacle of matter, the ancestor of the solar system, was disgorged. Unquote. But in paragraph 2 they tell us, the majority of solar systems, however, had an origin entirely different from yours. Paper 15, section 5, lists 10 ways that planets and other bodies may originate. Our astronomers would probably choose paragraph 3 as representative of the origin of our planetary system. Quote, cumulative spheres. From the vast quantity of matter circulating in space, small planets may slowly accumulate. They grow by meteoric accretion and by minor collisions. In certain sectors of space, conditions favor such forms of planetary birth. Many an inhabited world has had such an origin. Unquote. The authors do not mention a sun in this scenario, but it seems obvious that inhabited spheres would have a sun to warm them, and the particles that collide to form planets would be in circumstellar disk around the new star. The type of origin for our planetary system proposed by the authors of the Urantia Book is known as the tidal theory. It was proposed in 1918 by James Jeans, an astronomer. From the Internet, quote, as a result of detailed mathematical analysis, Jeans concluded in 1916 that the tidal interaction between the sun and a passing star would raise tides on the sun, resulting in the loss of a single cigar-shaped filament of hot gas, rather than separate streams of gas, as in the Chamberlain and Moulton scenario. This hot gas would then condense directly into the planets instead of going through a planetesimal stage. The central section of the cigar would give rise to the largest planets, Jupiter and Saturn, while the tapering ends would provide the substance for the smaller worlds. Unquote. This is parallel to the information in the Urantia Book. A competing theory is known as the nebular hypothesis. This was proposed by the philosopher Immanuel Kant in the 18th century and others later on. Both theories suffered from a problem with a physical quantity known as angular momentum. The tidal theory was eventually rejected as unworkable by astronomers. The nebular hypothesis was first rejected, but then re-embraced as some of its problems were resolved, and today the theory is almost universally accepted by astronomers and astrophysicists. The Urantia Book authors claim that the presence of retrograde motion is proof that the spheres performing such motion came from a source outside the solar system. In paper 57, they state, the 5 inner and 5 outer planets soon formed in miniature from the cooling and condensing nucleuses in the less massive and tapering ends of the gigantic gravity bulge which Angona had succeeded in detaching from the Sun, while Saturn and Jupiter were formed from the more massive and bulging central portions. The powerful gravity pull of Jupiter and Saturn early captured most of the material stolen from Angona, as the retrograde motion of certain of their satellites bears witness. All of the solar system material derived from the Sun was originally endowed with a homogeneous direction of orbital swing, and had it not been for the intrusion of these three foreign space bodies, all solar system material would still maintain the same direction of orbital movement. As it was, the impact of the three Angona tributaries injected new and foreign directional forces into the emerging solar system, with the resultant appearance of retrograde motion. Retrograde motion in any astronomic system is always accidental and always appears as a result of the collisional impact of foreign space bodies. Such collisions may not always produce retrograde motion, but no retrograde ever appears except in a system containing masses which have diverse origins." Unquote. Internet sources affirm that some of both Jupiter's and Saturn's satellites do have retrograde rotation. This means that they rotate around their axis in the direction opposite of the way they orbit their planets, as shown in the current slide. This fact and several others is difficult to explain with the nebular hypothesis, but astronomers have worked hard to explain away these anomalies. If the angular momentum problem for the tidal theory could be favorably resolved, then this theory could be serious competition for the nebular hypothesis. Later in this section, the authors discuss the characteristics of the worlds born by various methods. Our astronomers have no data to affirm or deny these claims, but they have discovered over 500 exoplanets at this point and obtained some information about the atmosphere of one of these planets. So at least we know there are many other planets in other solar systems, and who knows how much information we may eventually glean from our observations. Wouldn't it be exciting if we could someday confirm the existence of life on one of the exoplanets? This ends the fourth and final lecture on Paper 41.